Alright, I've attempted this video once. It cut off. I don't think I had enough space on my phone, so I apologize for the fact that stuff is already written here. But again, hopefully this is going to help you understand what's going on in this lesson. I'm going to have to repeat everything I just said, which is a little frustrating. So what I've got here is I've got a circle, and I've got a regular, using that term loosely, regular pentagon inscribed within this circle, which means each vertex is going to be a point on my circle. These darkened lines here, if this is the center of my pentagon, it's also going to be the center of my circle. So the distance from this point to any vertex of my pentagon is going to be the same because that's going to be a radial length. Each of those segments are radii. So in a regular polygon, all of your sides are congruent as well as all of your angles. So that's the definition of a regular polygon. So that means each one of these triangles here, 1, 2, 3, 4, and 5, are all going to be congruent to each other by side, side, side. That also means all these vertex angles here are congruent as well. Now this highlighted segment that I drew here is going to be the perpendicular segment connecting the center of my polygon to any of my sides of my regular polygon. That's what we refer to as the apothem. So the apothem is the perpendicular segment connecting the center of your polygon to any one of your sides. And this is going to be the distance from the center to any side because that's the length of the perpendicular segment connecting the point to the line. That's going to be helpful when we start trying to figure out what is the area of any particular regular polygon. With this pentagon, what I've started to do here, and I'll try to re-explain again, is this idea. If you go around your center point here, and I traverse all the way around, that's going to give me 360 degrees because that's the measure of a circle. So I'm just kind of spinning a 360 here around my center point. Now, a circle is made up of 360 degrees. If we look at these triangles, because each of these larger triangles are congruent, each of these angles are also congruent, which means if I take 360 and divide it by 5, that's going to give me a measure of one vertex angle here. In this case, 360 divided by 5 is 72. So each of these triangles has a vertex angle of 72. Now each of these triangles is also going to be an isosceles triangle, meaning that you have one pair of congruent sides. That also means that when I draw this apothem here, it splits my triangle into two congruent segments. That means it's going to bisect my vertex angle. So if this is 72, this angle here is going to be 36. Now this becomes extremely handy when we're trying to find the area of this polygon. So if you want to try to find the area of a triangle, the area of a triangle is 1/2 base times the height. And if all of these triangles are congruent, then I could say, all right, take this area and multiply it by 1, 2, 3, 4, 5. So in this case, the base is going to be the side length. Whatever that side length is, call it S. Let's say for this, because it's a pentagon, I'll call it 5. That's my base. If I want to figure out what is my apothem, then I'm going to use that length here in order to find that. So I'm going to call this A for apothem. If this is 5, the whole thing, well, let's do this. I'm going to make it 10 to make it a little bit easier. If the side length is 10, this apothem, this altitude of this right triangle is going to split my base in half. So if this entire thing is 10, each of these little pieces is going to be 5. So if I want to find this distance or the height of this triangle, which is also called the apothem in this case, I'm going to have to use trig using that